Assalamualaikum and good day everyone. So for this lecture we are going to focus on the third subtopic of chapter 1 which is the extremum of function of two variables. So last semester we have learned how to find the extremum point or the critical points, but it's for the if we have the only one variables. For this lecture, for this chapter, we are going to apply the partial differentiation. So at the end of this topic, students should be able to determine the stationary point AB by solving the simultaneous equations up to third degree polynomial. So what is third degree polynomial? Okay, we have power of 3 lah. And then determine the nature of stationary point. So we find out what is the stationary point, and then we need to determine the nature. Okay, so by using the second order partial derivative test, the same as the topic differentiation, the full differentiation. Okay, and then lastly we are trying to solve problem related to economics and business. Okay, so let's start with the extremum problems. So stationary points. Stationary point is a point on a curve where the slope is 0. This can be where the curve reach a minimum or maximum. Okay, so now we usually have the function with one variable, right? So we can directly sketch it in 2D form. Let's say this is our curve. Okay, this is our curve. This is x and y axis. Okay, so the slope is 0. So where is the slope 0? So we have this part where the slope is equal to 0. So this is the maximum point. And then we also have this part where the slope equal to 0. So this is the minimum point. So this is in 2D. Right, the function of y in term of x. But now we have a function of f in term of x, y. Okay, so this function is actually going to give you in the form of 3D function. Okay, so we can see the model. You can try to search in Google or YouTube. How does the partial differentiation look like? Okay, they will show you the 3D form of this type of function. Okay, so this curve, the point AB is a stationary point if f sub x equal to 0 and f sub y equal to 0. So we have two important characteristics to show that the point of AB is a stationary point. These two statements is really important to find out the point. Okay, so let's see directly the example for this problem. So find the stationary point of the function f of xy equal to xy minus x squared minus y squared minus 2x minus 2y plus 4. So this is our function. So we can directly find the f sub x and f sub y, right? Just apply the partial differentiation. So for f sub x, the first term we have xy, so y will be a constant. So differentiate x, we get 1. So it's 1y. And then for negative x squared, differentiate directly, we get negative 2x. And then for negative y squared, it's just a constant, so it will be 0. And negative 2x will be negative 2. And then negative 2y is a constant, 4 also a constant. So this is f sub x. And then the next one we need to find is f sub y. So this is our first step to find f sub x and f sub y. So f sub y. So the first term we have here is xy, so x will be the constant. So differentiate y, we get 1, so x multiplied by 1 is x. And then for negative x is 0. Right, this is only a constant. And then negative y squared, we get negative 2y. Negative 2x also a constant. Negative 2y equal to negative 2. And plus 4, 4 is a constant, so it will be 0 also. So now we have the f sub x and f sub y. To solve the point, we need to let both of f sub x and f sub y equal to 0. Okay, so it will be y minus 2x minus 2, the f sub x equal to 0. This is the first equation, and then f sub y, which is x minus 2, y minus 2 equal to 0. So we can find out the point x and y, the points of the stationary point, the coordinate for x and y, by solve it simultaneously. Okay, you can apply any method, either elimination or substitution. Okay, for this one, they multiply the first equation with 2, so we will get 2y minus 4x minus 4 equal to 0, and apply the elimination by adding the equation number 2 and equation number 3, sorry. So we have x plus negative 4 will be negative 5. X plus negative 4 is negative 3x, and negative 2y plus 2y equal to 0, and negative 2 plus negative 4 is negative 6 equal to 0. So 3x equal to negative 6 and x equal to negative 2. Now we can find out what is y. Y is equal to, by using the first equation, we get y equal to 2x minus plus 2, which is equal to 0. No, sorry. Y equal to, we can directly write down y equal to 2x plus 2. So substituting x equal to negative 2, we get negative 4 plus 2, which is y equal to negative 2. So the stationary point of this function is equal to negative 2, negative 2. Okay, so understand, huh? So the first step is to find f sub x, f sub y. The second step is to let equal to 0, and the third step is to solve the two equation by using the simultaneous method. Okay, so that's for example 1. Now the next step, the second learning outcome, is to determine the nature of stationary point by using the second order partial derivative test. Okay, so if we recall back the differentiation method in semester 1, we directly use the f double prime and then check whether it's a positive value or negative value or equal to 0. And then if it's more than 0, then it will directly equal to minimum point. Okay, less than 0 is maximum point. But now we have how many partial derivative for the second order? We have 4, which is f sub xx, f sub xyy, and f sub xy, f sub yx. So we will have this function that we need to follow. Okay, we need to use this formula to determine the nature of the stationary point. Okay, so what do we have as the result? This d, if we get it, the d equal more than 0, then f sub xx is less than 0. This is after we substitute the value of the point a, b, right? So after we substitute the value a, b into this d and f sub xx, if we have d more than 0 and f sub xx less than 0, then it is a maximum point. But if we have d more than 0 but f sub xx also more than 0, then it is a minimum point. However, if we have the d is less than 0, so another situation, then ab is a saddle point. So what is saddle point? Okay, you can try to search the saddle of the horse when you see how they're riding the horse. So we have the saddle on the top of the horse, right? So this is the saddle. So the point, this saddle is look like the saddle point, huh? So we have a saddle point here. Okay, so you can try search the saddle point, or if you have the jackal or the Mr. Potato, you can look at the potato shape. So we will have the saddle point there. Okay, it's in 3D form. And lastly, if d equal to 0, then for this one, if we have d equal to 0, then the test is failed. Okay, so we have 4 outcomes for the nature of stationary point. D is called the discriminant of f at x at point A, B. Okay, so this is actually the discriminant formula lah. So to determine the nature of the point, we need to use the discriminant formula. Please remember. So example 2, find the stationary point of the function. So we can use the example 1 as the guide and then determine its nature by applying the second order partial derivative test, which is the discriminant. Okay, so to find the first step is to find the f sub x, right? So f sub x is equal to 4x plus 2y plus negative 2. That's all. And then f sub y is equal to 2x plus 2y minus 2. So we have these two equations. The first step we done. The second step, we need to let both f sub x and f sub y with 0. Okay, so we have these two equations. And then what we need to do after that, after we find out the equation, we need to solve it simultaneously. So we have equation 1 and equation 2. So the equation should be 4x plus 2y minus 2 equal to 0 and 2x plus 2y minus 2 equal to 0. And then the next step is to solve. So because we have 2y on both equation, we can solve it by elimination method. So equation 1 minus equation 2, we get 4x minus 2x equal to 2x. And then 2y minus 2y is 0. Negative 2 minus negative 2 is 0. And the right side equal to 0 minus 0. So we have 2x equal to 0. So x equal to 0. Now if x equal to 0, y equal to, so substitute the value into equation 2. So we have 2 multiplied by 0 plus 2y minus 2 equal to 0. So 2y minus 2 equal to 0. So y equal to 1. So we have the point already, the stationary point, which is equal to 0, 1. Now to determine the nature. Determine the type of the stationary point, we need to find the second order of partial derivative. Okay, so f sub xx directly differentiate f from f sub x here. So we get 4x only on f sub x with variable x. So differentiate respect to x, we get 4. And then f sub y and f sub xy from f sub x also, we differentiate respect to y. So we have only 2y. So it will be 2. And then f sub yy, we differentiate the f sub y respect to y. So we have 2y. So the answer will be 2. And then we don't have to find f sub yx because f sub xy and f sub yx is the same. It's actually the discriminant is equal to f sub xx, f sub xyy minus f sub xy, f sub yx. But we know that f sub xy is the same as f sub yx. That's why we have f sub xy squared. Okay, now just substitute all of this value into the discriminant function. Okay, so f sub xx equal to 4 multiplied by x sub yy equal to 2 minus f sub xy squared. So 4 multiplied by 2 minus 2 squared, which is equal to 4. So we have the value of d is more than 0. And f sub xx is equal to, and our f sub xx is equal to 4, which is also more than 0. So what is this point? This stationary point is called the minimum point. So 0, 1 is a minimum point. That's the conclusion. Okay. So example 3. So let f sub xy equal to x squared minus 2xy plus 1 over 3y cubed minus 3y. Using the second order partial derivative test, determine the maximum, minimum point or minimum point and saddle point of the function. So what we need to do the same step as example 2. First, to find the points. After that, determine the nature of each point. So the first step is f sub x, f sub y. So f sub x, we have 2x minus 2y. And then that's all, right? We don't have any more x. And then f sub y is equal to, directly here, they directly find out what is f sub xx because it's easier like that. We can directly find f sub xx. So we have directly differentiate the 2x minus 2y respect to x, we get 2. And then f sub y, x sub xy, From f sub x also differentiate respect to y. So negative 2y we get negative 2. And then f sub y. So f sub y we get negative 2x and then y square plus y square and then minus 3. So for this value f sub yy, we also can find out the f sub yy which is equal to 2y. Okay, now we are done with all the derivative part. And then we need to find out the points lah. So to find out the point, we need to equate the f sub x and f sub y with 0. So f sub x, which is 2x minus 2y equal to 0, and negative 2x plus y squared minus 3 equal to 0. Okay, so these two equations, if we can see that actually we have y squared here. How to solve the y squared? Actually, the first equation can be written as a function of y in terms of x or x in terms of y. So rearrange the equation number 1, we get 2x equal to 2y, which is x equal to y. So we can replace the equation 2, the x in equation 2 with y. So what we have, the equation 2, or we can substitute equation 3 into 2 lah. So we get negative 2y plus y squared minus 3 equal to 0, which is a quadratic equation in terms of y. So we can solve the quadratic equation. Directly we get the value of y equal to 3 or y equal to negative 1. Now we have the y equal to 3 or y equal to negative 1, we can find out the x for each of the one. So when x equal to 3, when y equal to 3, x equal to 3. When y equal to negative 3, x equal to negative 1, x also equal to negative 1. So we have 2 points, which is 3, 3 and negative 1, negative 1. So we need to check each of these points. Okay, find the discriminant of each this point. So we have all the results already, right, in the first part of the solution. So what is the discriminant formula? It's f sub xx, f sub yy minus f sub xy squared. So for point 33, so the discriminant is suppose d is equal to f sub xx multiplied by f sub yy, so 2y, and then minus f sub xy squared, so negative 2 squared. So for point 33, we need to replace the y with 3. Okay, so we have the answer equal to 8. And then since d is more than 0, 8 is more than 0, and also the f sub xx, which is 2, is also more than 0, positive value, then this point 33 is a minimum point, right? And then for point negative 1, 1. So we need to replace the 2y here with negative 1. So what do we have? The answer is negative 8. Directly, negative 8 is a negative number, so it's less than 0. If it's less than 0, d is less than 0, means that the points negative 1 is a saddle point. Okay, so determine the nature of each of the stationary point correctly, following the guide. Okay, so now let's continue with the application of this subtopic, which is we are going to apply in economic and business part. Okay, so example 4. So this is the situation represented by the function. So the total revenue generated by a company for selling 2 products. So now it's not only one product, which is X or Q only, but we have the total revenue for 2 products. It's determined by the function R of xy equal to 150x minus 2x squared minus 2xy minus 3y squared plus 200y, where x is the price in RM for the first product. X is a price, and then y is the price in RM for the second product. Now the question is to determine the price. Okay, so what is the price? So we have price for first product and price for the second product, which is both represented by x and y. Means that we want to find x and y that the company should charge for each product in order to maximize the total revenue for the sale of 2 products. So usually it's revenue, it should be maximized. Revenue, profit, it should be maximized. Only cost, we want to minimize. Determine the maximum revenue. And then they ask you to determine the maximum revenue. Okay, now. So, how to determine the price means that we want to find the X and Y when we have the value at the maximum point. So what is the maximum point lah? Okay. So what do we need to do is to do the same thing as we have done in finding the stationary point and show that it is really maximum point. So how to find the maximum stationary point? The first step is to find the function sub x and function sub y. So r sub x and r sub y. So what is r sub x? So differentiate all of this partially with respect to x. So for the first term we have 150, and then the second term we have negative 4x, and then the third term we have negative 2y, and 0 and 0. So this is r sub x. R sub y, we will have the first term 0, the second term 0, the third term is negative 2x, the fourth term is negative 6y, and then the last term is plus 200. So we have r sub x, r sub y. So you can directly find r sub x, sub xx, r sub yy, and r sub xy, or you find out what is the x and y first. Okay, so the next step, okay, here, after we find out the r sub x and r sub y, the first step, we equate it with 0. So this is the second step, and then what we need is to solve the two equations. So we have 150 minus 4x minus 2y equal to 0, and negative 2x minus 6y plus 200 equal to 0. So solve these two equations simultaneously. So we can actually multiply the second equation with 2. Or if we want to eliminate the y, we can multiply the first equation with 3. So 1 multiplied by 3, we get 450 minus 12x minus 6y equal to 0. And then subtract the, so adding up between equation 2 and 3. So 3 minus 2, sorry. Subtract equation 2 from 3. So we get 450 minus 200 will be 250. And then 2 negative 12 negative 12x minus negative 2x is negative 10x. And then negative 6 minus 6y equal to 0. And then the right side is 0 minus 0 equal to 0. So we have 250 minus 10x. And then we have 10x equal to 250. So x equal to 25. So now we have the value of x. Solve for the y. Substitute the value of x into the equation number 2. So we have negative 2 multiplied by 25 minus 6y plus 200 equal to 0. So 6y is equal to 25. So these are the value of x and y, but is it really a maximum point, that give the maximum revenue? So we should check. How to check? We need to find the r sub xx, r sub yy, and r sub xy. So r sub xx differentiate second times, so we only need to differentiate negative 4x, so we get negative 4. And r sub xy, differentiate the y only, so we get negative 2y. So differentiate, we get negative 2. And r sub yy is equal to differentiate negative 6y only, so we get negative 6. So we need to check by using the discriminant formula. So r sub xx equal to negative 4 multiplied with r sub yy negative 6 minus with r sub xy square negative 2 square. So we have 24 minus 4, which is equal to 20. So the discriminant is more than 0, but the r sub xx is less than 0. What does it mean? It is indeed a maximum point. So the maximum revenue exists. Okay, so now we have the value of x and y when the maximum revenue exists. So what is x and y? X and y is the price. So the company should charge RM 25 ringgit for the first product and RM 25 ringgit for the second product. This is x, this is y. Okay, the price for the first product and the price for the second product. And then the next thing that you need to find is, so we need to find the maximum revenue. So the maximum revenue, we just have to substitute back the point into the our function. So we get out of 25, 25. So substitute the value, use the calculator, we get directly the revenue, which is equal to RM 4,375 ringgit. Okay, so that's one of the example in economic and business. So example 5. Okay, so the cost of producing X kilogram and Y kilogram of product A and product B respectively in RM 1000 is given by C of xy equal to x squared plus y squared minus 10x minus 2y plus 36. So now, what do we have here? We have information about the cost producing X kilogram and Y kilogram. This is talking about quantity, right? Okay. So the C is in terms of X and Y, which is the cost is depending on the quantity. Okay, so we have the function here, the quantity function here equal to quantity, sorry. The cost function here is C of xy equal to x squared plus y squared minus 10x minus 2y plus 36. To minimize the cost, find the weight of product A and B. So we want to minimize the cost. So we want to find the point where the cost is minimized. So the same thing we do for example 4, but here we want to find whether it's minimized or not. Okay, so now we want to find the weight of product A. So how many kilo? So what we need to find is only X and Y lah. Okay, and then the minimum cost. So the question here the same as example 4, except that it's talking about cost. Okay, so this is our function in terms of X and Y. To find the stationary point, we need to find the C sub X and C sub Y. So C sub X is equal to 2x minus 10 and then plus 0 plus 0. So this is the C sub X. C sub Y is equal to 2y minus 2. So both need to equate to 0 and solve it simultaneously. So we have 2x minus 10 equal to 0, 2y minus 2 equal to 0. So we don't have to use simultaneous because we only have one variable for each equation. So solve for the first equation, we get x equal to 5. And then for the second equation, we get y equal to 1. So directly we get the answer for x and y, but is it really minimizing the cost? So what we need to do is to check. So how to check? We need to use the discriminant formula. So what is the discriminant formula? We need to find the C sub xx, C sub yx, C sub xyy, and C sub xy. So C sub xx is equal to, so differentiate C sub x only on x, we get 2. C sub xyy, differentiate C sub y with respect to y, so we get 2 also. And then differentiate C sub x respect to y, we get differentiate equal to, here is, we don't have any y, right? So it's equal to 0. So substitute the value, we get into the discriminant formula. So we have 2 multiplied by 2 minus 0 square, which is equal to 4. So our D here is a positive, but the CXX also a positive value. 2 is a positive value. Okay, so what it means? So it's indeed a minimum point. So the minimum cost exists. Okay, now we have the point already, which is the value of x equal to 5 and y equal to 1. So we can conclude, hence 5 kg product A and 1 kg of product B need to be produced to minimize the cost. So the next question is to find the minimum cost. So what is the minimum cost? The minimum cost we'll have when x equal to 5 and y equal to 1. So just substitute the value of x equal to 5 and y equal to 1 into the cost function. So we have 5 squared plus 1 squared minus 10 of 5 minus 2 of 1 plus 36, which is the cost, the minimum cost that we will have is equal to 10,000. Okay, so that's all for this lecture, just an application of stationary point with its nature in business and economics. So please try to do tutorial question number 3 and 4. Actually, you can do 3 and 4. Really? Sorry, tutorial number 3 only. Okay? So thank you class. See you guys next Saturday. Okay, we will have a replacement class on Saturday. Thank you.